What I have here is a parallel circuit. Parallel circuit's the most common circuit in homes and industry. Everything is connected parallel. The hot and neutral wire, 24 volts in this case, are coming in and they jump hot and neutral to all four different loads. So every load sees the exact same voltage. Now, voltage measurements and resistance measurements, I'm going to take them all. If I touch my two test leads together, the resistance of my test leads are down now to 0.0 ohms, so there is no resistance. If I measure each individual light, we're picking up 7.1 ohms, 7.1 ohms, 7.1 ohms, and 7.1 ohms. If you read or watch the other videos in series and combination, you know these lights each are roughly 30 ohms each. But yet we measure it straight across from one end of the circuit to the other, and we're reading 7.1 ohms. Parallel resistances, the more resistances I add, the lower the total resistance is going to get. They add together inversely. So the more I add, the lower the resistance becomes. If we take that with Ohm's law, as the resistance goes down, current levels go up. Now as I apply power to this circuit, I apply power, we turn this to volts, AC voltage. What I'm applying here is going to be 24 volts of AC power. It's actually 23, but classified as 24. So every individual light receives the same exact voltage. You get 23 volts. 23 volts. 23 volts. Everything across from every point I measure would measure the same exact voltage of 23 volts. So the same voltage is applied to every portion of the circuit. Now, the difference is how current works. Now, I turn on my current meter, it's reading 0 amps. If I clamp around the wire coming in, power wire coming in, this circuit is drawing 0.27 amps, so 227 milliamps. That's 227 milliamps coming in. I measure the neutral. 270 milliamps coming out, 0.27 amps. If I measure the individual lights, the current will split and take different paths. We have 0.3 amps, 0.3. We measure the next one, 0.3, 0.3. We measure the next one, 0.3, 0.3. We measure the last one, 0.4 and 0.4. So all the currents split up in different paths. Every individual load draws its own current. And the total current coming in, 0.26 amps. The same current going out, 0.26 amps. This is how most homes and buildings are put together in parallel. And this is why we add breakers and fuses to the circuits to protect the wiring so the wiring doesn't melt. In a parallel circuit, consider your receptacles at work at home. Is it possible to plug one too many devices in and trip a breaker? Every time you add a resistance or add a load, the total resistance goes down, bringing the current up. So parallel circuits.